Hey, hello everyone. Thanks for joining. I think let's wait a couple of minutes to join everyone. Hey, hello everyone. So, welcome to the Academy. I'm Dhruval Prajapati, behalf on Aleph Academy team. And first of all, I want to wish you a very happy Halloween. This is the last Friday of the month, and as a like we are the Academy team back to the hunt. So here is like welcome to the beautiful session that has been conducted by the Rino. So first of all, let me give you a brief, some brief introduction about the Rino. He's our uh, Indonesian software engineer who is mostly working on the iOS development and all. So today he will be presenting on some of the solid topic, which is a solid principle with the VIPER architecture. So welcome to the session. And apart from this, for the academy, how this academy happens every last Friday of the month, and we have a bite-sized session in between of the month and every Wednesday. So, and if you where you can find the previous session is like you can visit our Medium articles. There is also like now academy team has started on the podcast as well. So we have recently one podcast out as well, and you can also like refer to the today's academy email where you can see the short video how you can contribute to the publications as well. So please feel free yourself to reach out to the academy member, Janaka, Emily, Moon, Andy, anyone to for the moving forward if you have any ideas in your mind. So let me pass now my ball to Rino. Like before I pass the ball to you, Rino, I want to ask you a few questions. So yes, so Rino, first of all, if you can introduce, then I will throw you some of the funny questions. Better to have your introduction first.
Okay, Drupal. Hopefully I can answer your question because you didn't tell me what our question previously. So yeah. Okay. Hi everyone. Thank you for joining, and let me introduce myself real quick. I am Rino Armadias. Currently, I'm in Aleph, Indonesia, and I've been working with my team here with iOS native projects. And a past year ago, I'm working with React Native for our clients, which is developing Android and iOS app using a React Native. So right now, I'm just focusing on iOS native projects. And for now, I just want to show you guys how Solid Principle works and the implementation for using the or following the Solid Principle using a VIPER architecture. So yeah, I hope this will be a great session with you all guys, and I hope we can get a discussion session, and yeah, I think everything will be fun. So yeah,
Yeah.
I'm ready for your question, Drupal.
Yeah.
What is it?
So some of the funny questions on your road. So first of all, as you know, this is the Halloween week. So first question I'm gonna ask you, like, which one is your favorite horror movie? It's a Jelangkung, which is an Indonesian horror, or a Conjuring, which is an international horror.
Well, that's gonna funny question. For Indonesia, I think yeah, I love Jelangkung. Especially the old one. I grew up with that kind of movie when I was a kid, and quite a scared out of me for that movie. But as a for right now in the modern movie, I think for the Conjuring, yeah, I like that one also. So yeah, I like both of them. But my favorite thing is the Jelangkung.
Yeah, So
It still
let me.
scares me.
Oh, that's perfect. I think I would recommend everyone to watch that movie. It's strongly recommended by Rino. Yep. So moving to the next questions. Your forte, Swift or Kotlin?
Swift or Kotlin? Oh god, that is a hard question, man. I really love both of them since it's the extension from Java and Objective C. Uh, but my current favorite, I think it's Swift because currently I'm working on it and kind of focusing on that language also. And yeah, I think for now, yeah, I love Swift more than Kotlin.
Some hardcore answer for the Kotlin lover, but I can understand. Yeah. So last but not least, like imagine if you're stuck on the desert. So which person you would like to stuck? Is it a project manager, a fellow companion engineer, or a tester?
Oh, sorry, can you repeat that?
Yeah. So if you imagine you're stuck on a desert, especially this is a
Mhm.
Halloween week, so don't be scared. Yeah. So what you want to choose by to stuck with? If you choose any one person, you accompany in that companionship in the if you're stuck in the desert. Is it a project manager, a fellow companion software engineer, or a tester?
Honestly, I'll bring my lead, Pukar. I think he's here. And yeah, if I'm stuck in the desert, yeah, I'll bring him here. I'll bring him here and accompany me to get through all of that.
Okay, okay, that's perfect. I think I don't want to eat up your mind now. Everyone is here. So once again, welcome. And my request to everyone, please feel free to shoot up your questions in the questionnaire chat on the side on the YouTube. We will shoot it to the Reno at the end of session. So please feel yourself free to post some of the questions. Over to you, Reno. Now, all the best.
Okay, thank you, Dhruval. And welcome everyone once again for joining. I think we can start right now, right, Dhruval?
Yes, yes, Reno.
Okay, for now, I want to discuss about solid principle and VIPER architecture. But before we continue, if you guys have some questions, just put down the comments in the chats, and after the session, we'll go through all of the question and try to answer it one by one. And please, if you have something in mind, some opinion that you have, just put down some comments. And I want this session to be like a discussion session. And so everyone can speak up. There is no wrong or right. So yeah, we can make this session as fun as possible. Okay, let's start right now. And the first thing I want to talk about is what is a solid principle? So solid principle is actually a mnemonic acronym for 5 design principles that are intended to make software designs more understandable, flexible, and maintainable. So actually, this is one of many principles that's out there. But currently for our OP projects or object-oriented programming, we tend to follow this principle called solid principle. And since it's an acronym or a mnemonic acronym, I'll show you what is the all of the solid means. But before I'll tell you what all of that means, just want to tell you for the first acronym, which is the S. It's a single responsibility principle. As for the explanation, I'll explain it later. And there is an O for open close principle. And then Liskov substitution principle. I for interface segregation principle. And last is D, dependency inversion principle. And so maybe you already have some question. Why should I follow this solid principle? So actually, the reason why we should follow or recommended to follow this principle, it is to make our code easier to maintain, better code testability, better standardization, and also the most important thing is to prevent duplication. So if you guys already know what try means, do not repeat yourself. Actually, by following this principle, it will actually help your projects better to maintain, and everybody who's joining, everybody new who's joined the projects will actually know the standard because we already set the standardization for our architecture. So everything will be better if we already have principle in our project. And this is why I very recommended to follow the solid principle. So about the testability, actually for the unit test, we can test our code better by using some mocks. And yeah, this will greatly help our project if we can stick to the principle, which is solid principle. So I want to talk about the first S, which is the single responsibility principle. What does that mean is a class should have one and only one reason to change, meaning that a class should have only one job. So maybe you guys are wondering, well, what does that mean? So I'll just give you an example, the live code example. So the first thing is the expectation. So right now, I'm going to switch to the project. So right now I'm opening a project for the iOS, but don't mind the codes. I just want to give you a quick example. So if you guys don't know Swift right now, it's okay. Just imagine this is a class that's doing one thing. We have a class called dashboard interactor, which is all what it's do. It just try to load a data from an internet or from API, and we call it fetch forms. That's it. That's the meaning of the first S for the single responsibility principle. So what is the wrong here? What is the catch? So what should be excluded from this class? So if we have a class, we should use a single task. So if you like put something to maybe inflate a view or showing a alert or everything in here, so it will violate the solid principle itself. So that's why the first S is the most important one. If you have a class, then you should have to put single responsibility just in that class also. So if you have, maybe if you need to show another view or navigate from another screen, then this is not the responsibility of this class. You have to put it somewhere else. And for the example, maybe I'll try to give you later, but please understand for the first S will be a first single responsibility for each classes. Okay, let's continue. Second is the O, or open-close principle. So what does that say? Is that object or entities should be open for extension, but closed for modification. Again, it's kind of hard if we just imagine. So I'll give you an example again. So right now, I'll give you an expectation. So the expectation is we have to, if we use the OOP or object-oriented programming, if we have our class to have some functionality and we want to expose it, it is very recommended to make an interface for that capability. So this is what's called for open or close principle. So we have to create all of our interface that have a functionality that we want to expose to the other classes. So again, this is for Swift, but this is very very generic for all of the other programming language for the OOP, because in Swift it's called protocol, but maybe in Java and in Kotlin it's called an interface. So this is actually the same if you already understand for the OOP or object-oriented programming. So we just have to create an interface for each of our classes. And if we want to like expose it into the public, then we should extend the interface itself. So yeah, that is for object open or close principle. Like that. So we'll continue for the third. The third is Liskov substitution principle. What does that mean is the LSP is stating that every subclass or derived class should be substitutable for their base and parent class. And once again, I'll give you another example. So right now, for the project, again, I'll give you an example, but right now I'm not using a project itself, but I just use a real world representation. Okay, right now I'll just give you a wrong example for the Liskov substitution principle. It says that every subclass should be substitutable between the parent class. So I think it's kind of confusing. What is substitutable? So I just give you an example right now, but this is the wrong one. So right now we have a class called engine. And this class will have a two functionality called getEngine and startEngine, which is correct, right? And engine can start its engine also. And then the second one is a transportation device. So our transportation device has an engine. We declare it, and we create also a variable called name and speed. And we have this functionality like getting its name, get speed, get engine, and start its engine. Okay. Next thing is a vehicle. So right now in vehicle file, we have two classes called car and bicycle. If you see our car, it is extending a class called transportation device that we already created before. Actually, in Java or Kotlin, it should be like this. I mean, in Java, but in Kotlin and Swift, actually it's the same. For extending an interface or a class should be like this. So actually, our car is a subclass of transportation device. And if you see, we have a capability, or the car has a capability to start an engine, which is, I think it's correct, because car actually can start its engine, right? Car has engine. But if you see on the bicycle class, now we can see the problem. If you see bicycle, is that doesn't have an engine. If you like imagine in the real world, bicycle doesn't have an engine. So I think right now we have a class that extending a parent class, which is not expected, or which just has a capability outside what it should be. So this is the wrong thing, and this is violates the Liskov substitution principle or the solid principle. And I'll just give you a correct example on how to implement it. Okay, the correct way to do. The first thing we just, and again, we create the same class called engine and same functionality again, get engine and start engine. And then we have another class, the same class, which is transportation device. But the difference now, we don't declare our engine in our transportation device, because if you know, the transportation device can be generic, right? It can be have an engine or not. So we want to make our class as generic as possible. So every other class that wants to use it actually does not force to have that capability outside that expectation. And now the difference was this. Right now we create another class called vehicle without engine. That is extending the transportation device. And also we create a class called vehicle with engine that is also extending the same class called transportation device. So actually now we have the two classes called vehicle with engine and without engine, but it will have a different capabilities. If you see in the with engine, we have, or we declare a variable called engine, and we create a functionality to start an engine. And if you see the vehicle without engine, it just have a capability to start moving. So actually the vehicle without engine will not have access to engine class. Now we see our implementation. Now we have two class here again, bicycle and car. So actually this is the same implementation like the wrong one. So the bicycle just extends the vehicle without engine. But if you see now, this is expected because bicycle can only have a capability to start moving. If we try to start an engine in here, it will throw an error, or the IDE will not even recognize it, because vehicle without engine doesn't have an access to engine class. So this is the expected, and this really follows the LSP or Liskov substitution principle. So once again, a subclass should extend the correct parent and have a correct capabilities. Okay, we're going next for the I, or interface segregation principle. So what does it say is that the client should never be forced on implement an interface that it doesn't use, or a client shouldn't be forced to depend on method they do not use. Okay, once again, sounds confusing, but don't worry, I'll just give you an example right now. So the expectation, we will be using the same, the analogy again for the bicycle and the car. And I just give you a wrong example first, okay? Right, the first wrong example. Okay, right now we have the same class again, like we previously implement. Right now we have a class called engine, and we have certain capabilities in here for getting its engine and start its engine. And then we create another class called transportation device. But right now we have some difference. The difference is we create an interface called maintenance. So in Swift, again, this is called protocol, but in Java or in Kotlin on other OOP projects should be called interface. So it's actually the same. So right now we have a interface called maintenance. And we have two capabilities here called change spare parts and change engine. So we make our class transportation device to extend the interface itself. So the IDE or the program will be force us to implement it, because if we not implement it, the IDE will throw an error. Since if you use an interface, we should implement what is inside that interface itself. So right now, if you see our transportation device will have a capability from maintenance called change spare parts and change engine. Okay, and then we see the implementation for our vehicles. The first thing, we again create a class called car, and we extend our transportation device. And if you see, the car can have access to change its engine, so it looks good. The car have an engine, right? But for bicycle, I think we have something wrong here. So once again, same like the LSP violation, our bicycle can access a function called change engine, which is, if we interpret it into our real world, yeah, actually bicycle doesn't have an engine, right? So actually this is very similar like the Liskov substitution principle or the first the L, but the difference was this is for the interfaces. So for the Liskov, it's a violation for the function that that class have, but for this one, this focusing more on the interface itself. So this is the wrong example. So I'll just give you a correct example on how can we not violate the ISP or the interface segregation principle. So again, we create a class, the same class called get engine and start engine. We have that same functionality. And then again, we create a class called transportation device, but right now we have some differences here. If you see, we don't have an interface again right now. Previously, we have an interface called maintenance, but right now, once again, we create our transportation device as generic as possible. So our transportation device just have a name and speed, and then it can get the name and get the speed. Now, the difference now is we have another class called vehicle without engine. And now, if you see, we are extending two things here. The first thing is the transportation device, which is the class that we already created before. And we have an interface called maintenance part here for change spare part. So right now, if we already implement this in our class, the IDE will force us to implement it, right? Change spare part. And then if you see on the vehicle with engine, it's actually the same like the Liskov substitution. For the vehicle with engine, we'll have an engine itself. But again, the difference is the interface. The interface is different than the vehicle without engine has, because in vehicle without engine, it has a capability to change spare parts. But for the vehicle with engine, it just have a capability to change its engine. Okay, so let's see for the implementation. Now, again, we create another two classes called bicycle and car, the bicycle will be extending the vehicle without engine. And if you see right now, we can have access from the interface that we already, from the function that we create in our interface called change spare part. And this is expected because, again, bicycle doesn't have engine, so it cannot access to start an engine. But for our car, we are extending a class called vehicle with engine, and see, we can call a function called change engine. So this is the expected one, but more focus on the interfaces. So yeah, that is the example for the correct one. Let's continue. Now, the last thing is the D, or dependency inversion principle. So what does that mean? That we must depend on abstraction and not a concrete class. Well, it's a really quick explanation and it sounds confusing. Okay, I'll just give you an example again. And right now, I'll not use the bicycle and car again. So I'll give you another new example for the dependency inversion principle. So right now, I'll just give you a wrong example. So for now, since we are not using a bicycle and a car, again, we are now using like an example for getting the customer data. So this is just an example, a simple one. So right now, we create a function to get a customer name. And we are asking for an ID, and we are returning a data string. So if you see, we are returning a hard-coded string. So this is just for an example. So yeah, we create a class called data access, and we create a function to get a customer name. And now, again, we create a class called data access factory. So this is usually in a real project. We used to process our data when we get the data from our data access. So like maybe you want to store it first and then pass the data. Yeah, you can do it here. But again, since this is just an example, I just showing you a very simple thing, just to return the data access itself. Okay, and then for the implementation, this is when the user asking for the data. So I just call it a class called data customer logic, but this is where we need the data itself. So right now, we declare again the data access, the name, and then we call a function called get data access object. And I think if you see this, you see nothing wrong, right? So if you try it and implement it into a real project, and actually this should work, because there is nothing wrong for the implementation in here. But actually, if we refer to dependency inversion principle, it will violate the principle itself. Because why? Because right now, we create a data access factory, which is returning our class itself, a data access. And this is a violation because this is in a solid principle, or especially in the dependency inversion principle, it is very discouraged that we expose our class and just call that functionality directly. Again, we should make it as an interface, and then we implement that interface into our users. So yeah, since we are exposing our data access class, then this is violation for the dependency inversion principle. So I'll just give you a correct example on how to implement it. So once again, we actually create the same class, data access, and we have a functionality, again, get customer name. But right now, the difference is, actually, we expose the functionality from our interface called a data access interface. And then our class just extends our interface itself. So again, the IDE will force you to confirm the function, because again, if you like extending an interface and you do not follow the variables or the functionality that the protocol has, it will throw you an error. So we have to create this one. And then we create the logics and see in here. As you can see, this is the same implementation with the wrong one. But the difference is, in previously, we are returning the class itself. But right now, what we are returning is the interface itself called protocols in Swift. See, there's a difference here. So right now, we are returning the interface, not the class directly. And we see the implementation when the user need to access the data. So the first thing that we declare the interface itself, and then we initialize it using our data access factory. And then actually we can get the customer name function. So actually for the implementation is actually very similar with the wrong one. It's just the abstraction that's been done in the background. I mean, in the data access. So yeah, that is very, we are very encouraged to like create an interface and abstract a function that you want to make it public. So yeah, that is the dependency inversion principle. Let's continue. Yeah, the summary is the idea of applying the principle in software project is to take an advantage of the benefits of using object-oriented paradigm correctly. So we can avoid problems such as lack of code standardization, duplication, and uphold your code as dry as possible. So like I explained to you earlier, so this will greatly benefit your project if you guys follow the solid principle. But maybe you guys already have another question. Okay, maybe I already understand what is the solid principle, but how can I implement it into a real projects? So after this one, I'll just give you an example for implement or to follow the solid principle using a VIPER architecture. But before we continue, maybe you guys have some question, or Dhruval, maybe you can help me go through the question and we can just answer it real quick.
Yeah, so there are the plenty of suggestions that one of the suggestion from the Gamal is there JavaScript example, please. I think he really liked the explanation, but I think we can relate to the classical, if there is a classical approach in JS now. So I would suggest like refer the javascriptinfo.com from the web perspective, because I'm coming from background. That is a really good source to refer. So one of the questions from the Antares is that when we were explaining the abstraction, so he was asking like based on the solid principle, we need many abstractions, right? Especially when there is a many same use cases. So what's your take on this?
Okay, so actually it depends on you guys or what your team agreed. If you want to abstract all of your functionality, or when you want to make it a public, then if you really want to follow the solid principle, then yeah, I think you have to expose it through an extraction of the interface, because maybe before you're implementing it and you already feel down, like this will make our codes like bloated or increasing our size. But maybe you can think for the benefit itself. The benefits are when you are creating a unit test, actually you can create a mock from the interface itself. So rather than you just accessing the property or the functions that the class have, you can actually create a mock for the function, like from the start of the beginning of the implementation, from the process and till the end of the process, you can see whether your functions are working correctly or not. So yeah, I think, but I'll throw it back again to you. Like, what is your priority? If time is an essence, then yeah, I think it's okay to violate one or two things. But if you really want to follow, just yeah, that is a very recommended to abstract all your public functions.
Yeah. So there is a one more suggestions from the Hassan as well. The more abstract you use, the more engineering your works. So there is a suggestion from the Hassan as well. So apart from this, like there was a few of the questions from the Janaka on the plain JS, like how we can ensure the same principle using the plain JS. So here I want to jump in a bit because I'm coming from the web background. So actually, the JS has been evolved through the syntactical sugar a lot. Like there is a classical approach has been introduced later on after the object-oriented design principle and the TypeScript as well. So I think if we use a TypeScript, then there is a TypeScript abstract classes and the interface are there that can be useful in the JavaScript to implement this kind of feature, because vanilla JS is not a classical language. So like we have to tends to rely on the some of the features that have been introduced. So one of the questions from the Andy to you is that what challenges you face while working on these solid principles?
So for me personally, the main challenges actually is the deadline. Yeah. So if you see, if we create and we want to abstract all of our function or the capability that we have, actually it will take time since we have to code more, right? So yeah, if again, the problem is when there's a deadline and suddenly our rainbow mode is on. And yeah, we tend to violate and we didn't realize that we already violate the code itself. So yeah, I think that still needs to be figured out on how can we manage the timeline better and how can we follow or to minimize the problem itself. So yeah.
Okay, correct. So I think there's a quick chats and interaction between the Gamal and Hassan and Janaka. So I think we can now move forward to the VIPER section of yours. So what do you mind? We will take
Okay.
questions later on after that.
Okay, great. Thank you, Dhruva. Okay, guys, let's continue. So here's all the thing for the solid principle. And right now, I want to show what is a VIPER architecture. So actually, VIPER is one of many architecture that exists in the world. So actually, what is the purpose of using an architecture is actually to follow a certain principle. So for the VIPER architecture, is really follows the solid principle itself on the baseline. So it separates our code much further by single responsibility. And also the VIPER is a mnemonic acronym, same like Solid has. So I'll just show you what is the first fee are. So the first fee is called view, which is the user interface. And this is where you show a view to a user, or maybe like a button or text field. Next is our interactor. Interactor actually a class that mediates between the presenter and the data. So I'll get back on this later. And we have a P called presenter. Well, presenter many called the traffic cop, but I personally called it's a broker or a courier. So it's the courier of the architecture that which is directing the data between view and interactor. So remember, interactor will be used to process a data, like fetching an API or saving data to database. So presenter will be a middleman for the view and the interactor itself. And also, if this is stated that to call a router, so I'll get back to what is the router. We're going next for the E called entity. So actually, entity, we can assume that this is just a model. So a model is to represent the application data that we get outside of the apps or we have inside of our apps. So we just want to create a structure. So many of us just call it a model. And last R is a router. So this handles navigation between screen, but not only navigation, everything that's related to show or hide a view, like showing a model, hiding a model, maybe show an alert, it will handled by our router. So so the presenter will be a crucial part in here. So I'll just give you the map here. So we have a flow right now. If you see, we have our view layer, which is the UI or the screens that shown into the user. And imagine that the user wants to load a data from an API, which is the API has in an interactor, right? So for now, the view must request a data from our presenter. And then our presenter will carry on the instruction to get the data from the instructor. So while we're waiting asynchronously, and then the interactor just giving us the data, like maybe top 10 list movie in the 2020, and then just passed it again to the presenter. And then the presenter will try to pass the data to our view, and then try to reload the view, and boom, the view will be updated. So it's kind of unique, and maybe you see there's a many layer, and it's kind of complex, but actually if you already implement it and if you test it in your current project, I really feel you will get a great benefit if you follow this one, because if you already follow the VIPER architecture, you already have some mindsets. This is a personal opinion. So you already have the mindset like, if I have an issue in my fetch data, then I just have to go through to the interactor. I don't need to like search a file, like maybe in if previously if you're using FEC, just search it, where's in the VR controller, where's the fetching the data itself. So I just like already have a combat mode to search the fetch in the interactor and see where's the wrong thing. Or maybe if I have some issue in my view, maybe the button showing a wrong color maybe, then I just have to see it in my view. So yeah, that is the benefit of a VIPER, because since we already know each of the layer have its own responsibility, you will already know where to look, so to speak. Yeah. So yeah, that is the overall for the architecture. And right now, actually, I already create an example for Android and iOS. So I'm sorry if I'm actually bad at design, so I just create an UI so simple, but at least this is working for following the VIPER architecture. And if you guys want to clone the GitHub, just please scan the code and try to clone it. And maybe if you guys later have some question, you guys can raise some issue in the GitHub, and I'll try to answer it the best I can. So maybe I'll just like to showcase the project real quick. So I'll just showing you the first example for the iOS app. So right now, if you see, we have a modules, actually two modules called dashboard and movie detail. So I don't want to like give you an example from scratch. I just give you a general idea on the uniqueness of the VIPER itself. So we can just focus in here in our interface. So actually, if you see VIPER, we have a view, we have an interface or interactor, and we have presenter, entity, and router. Now we just have to create all of that thing or the interface in each of our modules. So for our wireframe, we create an interface called dashboard wireframe interface, which has a capability to navigate. And then we create a presenter, we have a variables called movie list, and this is our model or our entities movie list. Also, we have a view interface for our view called reload view, just to reload the data, reload the view. And lastly, we have interactor interface to fetch the films. So I'm sorry, I cannot like dive to detail in here. So I just try to show you the interfaces that VIPER has. So for the Android, it's actually the same. We create the interface also. So if you see again, we have two modules in here, dashboard and details, because we have the same application. And for the dashboard, we will have an interface called view. And then we have an interface called presenter, which is, if you see if you compare with the iOS, it will have the same functionality. So yeah, this abstraction really helps if you like have two projects with the same application. So, and if you guys want to compare it, yeah, I think it will be easier, so to speak. So if you know you guys have the same logic and some same capabilities for each of the framework. And again, interactor for fetching the movie list, and lastly for navigation or navigate to detail. So yeah, this is the example for the app, but maybe for the details, you guys can explore it yourself and try to see in the GitHub. And again, if you guys have some question for the codes, just raise an issue and I'll just answer it. Okay, I think that's all for the solid and the example for the VIPER architecture. But before I close this one and jump to the Q&A session, I just want to give you some quotes. So actually, what I said before for the principle and the architecture, actually, that is not the best thing, or that is not the perfect thing you should follow. What I said earlier is just a reference for you guys to follow and your team to decide. And actually, the best principle and the best architecture is the one that your teams agreed on. So yeah, if you guys already decide on like what architecture you follow, or what principle that you should follow, if your teams are agreed with it, then go with it. That is the best of principle or the best architecture that your team has. So yeah, I think that's it. Let's jump to our Q&A session. Dhruva, I'll give it back to you.
Okay, I think that's quite good explanation on the top of solid principle. So there's a few questions from the Janaka that this particular VIPER is for iOS only. Can be used in Android web apps or Android like any other applications?
Okay, actually, we can do it for the Android also, since Android are using OOP or Kotlin for the object-oriented programming. So yeah, we can also make that happen. Actually, I already create the example. So for Android dudes that wants to try or wants to explore how these things work within the Android itself, so you guys can clone it. And yeah, maybe it's kind of alien to you, like there's so many interface that we have. But yeah, I think this is a really good example if you guys want to learn VIPER in Android.
Okay, perfect. So moving to the next question, I think Praveen asked that where should we write the repository logic inside the.
Okay, the repository means, oh, okay. So it actually depends on you. So actually, if you want to make your repository as a service layer, then it's fine. Then it will be outside of the VIPER. The VIPER is just a layer for the interactor. It's just the layer to each of the modules. But if you want to create a repository within your own current modules, then it's fine. You can like make it another class, and then the interface or sorry, the interactor just extend it, then it's fine. But if you want to make a global repository for all of your service or APIs, then again, it's fine. So as long you abstract all of the things that you want to make public.
Okay, so I think there was one more question from the Janaka as well, where he asked about the difference between MVM architecture, which Andres explained a few points. Like he explained, like we didn't need to implement view interfaces in MVVM. So the view is actively observing, like it's a more of an in web we call web sockets observing each of the live data. But what's your take? Do you see any other difference in MVVM for that if you compare to VIPER?
Yeah, actually, the different the big difference is where's the abstraction is going, because for the VIPER actually is a higher level of abstraction, and MVVM maybe yeah have some service layer, but for the details, I'm sorry, I didn't explore it very much because in my current project I haven't tested it. But as far as I know, for the MVVM, it's kind of different based on their abstraction. So yeah, correct me if I'm wrong, Antares. So hopefully it's answer your question.
Yep. So I think that helps cherry on the cake for the suggestions which Andres wrote. So just on two more questions from the Praveen. So first one is it possible to implement dynamic navigation with the VIPER? And the second is a VIPER and CleanSwift architecture are different? So you can go with the first one. I will repeat the second question for later on.
Okay, dynamic navigation. Actually, yes. You can do that dynamic navigation So it depends on you how you structure your base project itself. I mean, the base navigation or the base view controller. So yeah, I think it is possible because the Viper itself, it's just an abstraction modules that every class should or every module should follow. So if you want to make a dynamic navigation, then it is possible, but it depends on how you implement it. And if you already know the risk, if you already implement it for the implementation, then it's fine. If you already think it's fine, then just go with it. But I think it's actually possible.
Okay. And the second question from him is a Viper and the clean Swift architecture are different?
Sorry, can you repeat?
Is Viper and the clean Swift architecture are different?
Viper and
Clean Swift.
Clean Swift. Oh, sorry. I haven't heard of the Clean Swift. Maybe I'll try to read more on that. Since, to be honest, I really new in the Swift world. So yeah, maybe I'll try to read more on that.
Yeah, I think it's a commendable job you done in explanation. That's I think we can later on get in touch of some of the like Andre, someone to get more details on that. So I think Praveen, that can help you. The explanation of Reno can help you to understand from the one of the questions. If you have more question, you can please feel free to shout out on the chat. So one of the agreement that Ragil have like typed before, like prefer duplication over the wrong abstraction. So what's your take on this one?
Okay, let me read through.
So he said like always prefer the duplication rather than writing the wrong abstraction. So which Jessica also agreed. But what's your take on this one?
Yeah, so actually, again, it depends on how you write it. So actually, if I see the comments, the last comment that Ragil said, so once again, you'll challenge to have a broad view of use case or you're lost in your code. So yeah, it depends on how you abstract your code itself. And because if you want to abstract your code, it is actually easier to test it, but maybe it will have some implication like your code is getting bigger. But yeah, for which who to follow, yeah, I think best to discuss with your team also and what is you guys are agreed on. So yeah, I think that is my stake on that. I cannot like what should you guys follow, and yeah, I'm trying to be neutral here. Neutral, yeah, neutral.
I think Andy and Pukar asked the same question. I think Pukar answered himself as well. Like, what is the disadvantage you feel like of using this Viper architecture?
Yeah, Pukar just answered his own question, by the way. So yeah, actually, for Viper, yeah, actually it will increase your file size, but not so much. But the main problem is kind of quite hard for new joiners, or if you have a new teams and they haven't touched Viper yet, the learning curve is kind of big. Because to be honest, the first time I learned iOS, I learned for the default MVC. Then when I go through the Viper, it's kind of overwhelming for me because all I can see is this very much class or very much interfaces and abstraction. So the first new joiners kind of will be confused and will have tougher time to learn other than using other architecture. So yeah, I think that is the main disadvantage for the Viper.
Okay, perfect. And I think Ranga also at one point that for one page you have to create almost 11 to 12 classes.
Yeah. Well, actually, it depends on how complex your projects are. But yeah, I think you can optimize. Doesn't it 11 or 13, man? Because right now, I don't think for each of the screen will use 11 or 13. But yeah, I think it depends on how you optimize your functions. Maybe you can create your functions to be public function and generic functions and make it a service so every modules can access that. That will help to decrease your classes, right? So yeah, once again, it all depends on how you guys make things complicate or make things much bigger, I think.
I think, but struggle at start will enhance the efficiency at last. So always adhere this kind of object-oriented design will always work out for any development, like either is a mobile or web or anything. So one more question from our pioneer of SG in the iOS development, Praveen. So he's asking like, is one screen can have more than one presenter or one interactor?
Okay, so for now, I don't think it will be wise if we have more than one of layers for each of the modules. Well, if you design your apps to be support for many of the layers, but I don't think there is a point in that, because we want to focus each of our layer into one class, which is like maybe in presenter only that, and I don't think it'll be wise if we create another presenter in the same modules, and I don't see the benefits of it. So maybe you can do that, but I don't think it will be like greatly benefit you to help you with the projects.
Okay, I think Pukar also second your thought in the chat. So, and also like Entres and Sarthak both says like this VIPER architecture is go well with the testability as well. So I think that is one of the advantages add along with like efficiency. So few of the comments from Ragil as well, which I want to just speak on the screen is he loved the term of chain interceptor or pipeline processes rather than MVCC. So he also have a like more indentation toward this Viper plugin, because the most of the important is the data, and you want to process the data rather than busy think what the proper layer to add this process. So I think there are the proper solid indentation toward the architecture like this, and also like in the web we have also on top of this we have a like a object oriented design architectures, which is a dry case and all, so which help to like on the longer run. In the start it's struggle to implement, but in the longer run and the manageability, if you see, it's adding advantage. So I think
Agree with you.
most of the questions and like most of the good chat in the YouTube as well. So I think I want to also thank them who discussed during this chat, adding advantage of having the knowledge. So first of all, thanks to you as well to present this beautiful topic, which I think applicable to any environment. So I think, and thanks for all the joiners who have joined in this Friday evening. So once again, I would say please spread the word. Please spread this session to every one of your friends in the same development. Thank you everyone for joining this. So don't forget to follow Academy team on the Medium article. We have now a publication of podcast as well. You can follow the today's mail to see how we can publish the publication using Aleph Academy. So I strongly suggest you stand up and give your suggestions. Feel free to shout out to Aleph Academy team. So I think that's it from Aleph Academy side. I wish you a very happy Halloween once again and a very good weekend ahead. Thank you guys for joining.
Thank you everyone for joining.